Before we start, make sure everything here is drawn onto your page. You need your congruency statement, you need the pictures, and you can either fill in on the lines over here, or you can fill into your picture is fine. The first thing you should do is go through and mark your congruent parts. So G and X are congruent since they are both first. So I will mark G congruent to angle X, and H is congruent to angle Y, and angle J is congruent to angle Z. Well, we can also notice that as our sides, GH is congruent to XY. It already has one mark, so I'm just going to give it one mark as well. When we mark HJ then, it also only has one mark since it's congruent to GH. So I know that YZ can be marked the same as well. What that means is we have an isosceles triangle. All four of these sides are congruent to each other. In an isosceles triangle, if you have two congruent sides, you also have two congruent angles, the angles across from them. G is across from HJ, and J is across from 27, the HG. So I'm going to change this from having 3 marks to having 1, since these are congruent as well. What that means is I can change it up at Z also, so those are congruent. Lastly, we know that GJ is congruent to ZX. Having your picture marked will make it really easy to fill in everything else we know. So GJ is congruent to ZX, which means that I know GJ is 18 feet. XY is congruent to all of these other segments right here, so I know it's 27 feet. And I know that ZY is 27 feet. Angle H is congruent to angle Y, so I know it is 38 degrees. Angle Z is congruent to all of the other 4 actually, so we can figure out what all of these are. If angle Y and angle H are both 38 degrees, that means G and J, for example, have to share the rest of the triangle. So we can do 180 minus 38, and we know there are 142 degrees left over, shared evenly between these two angles, or if you're looking at the other triangle, Z and X. Since it's shared evenly, we know these angles are equal. We can cut that in half, and I know all of my missing angles are 71 degrees. So angle Z is 71 degrees, and angle J is 71 degrees. We will check our homework answers next time and make sure that we're good to go on that. Please, we will collect these today to make sure that I have them and I can stamp them, and next time we will fill in both this URL and go through the answers together. Today we're going to start triangle congruence. We are only going to do 2 of the different methods. We are specifically going to do side angle side, or side side side, and side angle side. Make sure that this is the title above your do now in your notes already. It should be posted on the back board, so you should have already written that down for yourself. In order to prove triangles congruent, if you go based on the definition of congruent triangles that we talked about last time, you would need 3 sets of congruent sides and 3 sets of congruent angles in your proof in order to tell me that the entire triangles are congruent. So you would have to have 6 different congruent statements before you could tell me that the triangles were congruent. Mathematicians hated this, so mathematicians found 5 ways to use less information and still guarantee that triangles are congruent, and we are going to start learning those today. I'm going to go over 2 of them here. We'll do the other 3 next time, but these are going to be your different ways that you can guarantee your triangles are congruent. So make sure you have all that written down, and then we're going to go into the first way to do it. The first of all 5 methods is called side, side, side. We abbreviate this as SSS. What side, side, side tells you is that if 3 sets corresponding sides in 2 triangles are congruent, then the triangles are congruent. So in your proof, if you can find me 3 sets of sides instead of doing all 6 sets of sides and angles, then you can tell me that your 2 triangles are congruent. So I'm going to draw you a picture. You draw this in your notes that you have the example, because the visual is extremely important. We're going to go through and label everything in each proof also. So here I will just mark it so we can talk about it. What this would look like in your picture, you would have to know that AB, say, is congruent to DE. You would have to know that EF is congruent to BC, and you would have to know that DF is congruent to AC. But if you have a picture that looks like this, then you can guarantee me that triangle ABC is congruent to triangle DEF. Remember, your order matters there. And your reason in the reason column would just be SSS because of this theorem. If 3 sets of corresponding sides are congruent, which we have in this picture, then your triangles are congruent. We're going to do a couple examples of this, so go ahead and write all of this down in your notebook. You need the picture, you need the given and the proof. Feel free to pause this video to give you time to copy all of that in. When we start our proof, we always fill in our given. You guys know that already. Yes, you have to write all of it. No, it's not that much. But the other thing that you need to do along with your given is to mark your entire picture. Make sure you have your visual to know what you know already and what you need to find. We know PQ is congruent to ST from our first statement. We know QR is congruent to RT. And then we have this last statement here. If we are trying to prove this by side, 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 we need one more set of sides congruent, and you either need to get that from your picture alone, which we'll see in another example, or from the rest of your given. If we know R is the midpoint, what that really tells you is that R cuts PS in half. So PR is congruent to RS, and that is going to be our next statement in the proof. This we've done before. It is the exact same as when we did our segment and angle addition proofs a couple chapters ago. PR is congruent to RS, and your reason is the definition of midpoint. That's what word in the proof told you that was true. Now, if you look at your proof, we have one set of segments congruent, we have a second, and now we have a third, which means we can say the entire triangles are congruent. Whoopsies. What I would look at always, they give you a congruency statement here for now, so go ahead and use that exact one to make sure you are writing it in the correct order. And your reason is just going to be side, side, side. For our next example, same kind of thing. Go ahead and write everything in. You need the entire given and prove, and you need the picture. It is extremely important, otherwise you won't know where you got things from. So I already have one congruency statement. that I can use. If I mark it over here, JL is congruent to MN. So far, the only reason you guys know to prove triangle's congruent is side angle side. Or nope, side side side. Side angle side is next. So we have to look at the rest of our given in our picture to find two other sets of sides. K is the midpoint of two different segments here. So if K is the midpoint of JN, just like on the last one, we know is that these two parts are equal, so JK is congruent to KN. Since K is the midpoint of LM, we also know that LK and KM are congruent. For your statement to tell me all of that, you can put it into two statements or one. I do not care. So you can do JK is congruent to KN and LK is congruent to KM. You can put those together because it is the exact same reason. You know both of those because of the definition of midpoint. Do not group things that don't have the same reason, but if they have the same reason, you can group them. This one, now I have all three sides congruent. I've told you all three sides in the proof. So your final statement is that triangle JKL is congruent to triangle NKM, and your reason again is side, side, side. Take a minute, make sure you have all that copied down. If you have any questions, feel free to rewind this or go backwards. The next one that we have is called side angle side. So this is your second of 5. Similarly to side, 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 we abbreviate it by putting just the 3 letters. What this tells you is that if two sets of corresponding sides are congruent, and one set of corresponding angles and very importantly, these need to be the angles between the sides that are congruent. So the sides we've talked about up there, it needs to be the angles between them are congruent. Then the triangles are congruent. This one is especially important to have a visual, so make sure you draw these. So for example, if I knew this side was congruent to this one, and the bottom one is congruent to the other bottom one, the angle that you would need would have to be the one between these sides. So if you drew over both of them, it'd be the angle you are outlining. So it is that angle right there, as well as this one over here. What's very important is the order again. So if you had these two sides, you cannot use the angle outside. That does not work. It has to be the angle between the two sides. It's extremely important on these to have right order, or you cannot prove the triangle is congruent at all. And we'll talk about that later when we get to reasons that don't work. Again, go ahead and write all of this down. You need the given, you need the proof, you need the picture, you need everything. In the notes, I have broken it apart. So we're not doing side, side, side anymore. We're literally just looking at side angle side. In your homework, it will not be like that, so you are going to have to keep an eye out. It'll be especially important that you are marking your picture and paying attention to what I gave you. But if we mark JM and NL, it is these two. The angles are usually a little trickier to mark. When we learn to name angles, we talked about multiple different ways, and one of them was using 3 different letters like we did here. If I give you 3, remember that the middle one is your vertex. So this angle right here, JMN, the vertex is here at M. But as you look at M, there are 3 different angles. You have this top one, you have this small bottom one, and then you have the whole thing. So we have to know which one is which. You are outlining the angle as you read the name. So you start at J, go to M, and then go up to N. So the angle that we are marking congruent is going to be this top little piece at angle M. You do the same thing for this side, LNM. So we are looking at that angle right there. In order to prove side, angle, side, we already have a side, we already have an angle, so we need one more side. To go in the correct order, the side has to be this MN right here. What's extremely important is to notice that that is the same side in both triangles. So of course it has to be equal to itself. We have actually talked about this property multiple times. If you look back at your segment proofs reference sheet, the very first property listed is called the reflexive property. This one is extremely important. So we are going to star it. Anytime you want to tell me something is congruent to itself, so if you have a shared side, exactly as this is right here, you will tell me the segment's congruent to itself, and your reason is the reflexive property. If you go back to your segment proofs reference sheet, that is again the first one listed, and that's exactly what it says. Anything is congruent to itself. The nice thing, now that we have that, we have two sets of angles congruent. We have the sides between them congruent. So you can now successfully tell me that yes, the triangles are congruent to each other, and your reason is side, angle, side. Again, take a minute to make sure all of that is written down. If you have questions, feel free to rewind or to ask your classmates. Make sure that everything there makes sense. The only new thing should be this blue thing right there. When we do these proofs, one thing I will stress is that absolutely everything we have done all year is fair game. So this proof is especially important to make sure we see that. So go ahead and write all of this down. So that first statement there tells you that HI and GJ are congruent. The second statement tells you that they are also parallel. If I'm looking at my proof, I'm trying to figure out how to prove these congruent. So I know I either need all three sides congruent or two sides and the angle between them. Looking at this, I know HJ is included in both GHJ, which is one of the triangles, and HJI, which is the other triangle. So I can tell myself that it is congruent to itself, or in the proof. We're going to use that just like we did the last one. Reflexive will come up quite a bit. But anytime it's shared, tell me it's congruent to itself, and the reason is the reflexive property. And we need one more piece of information. One thing to note, there is nothing told to you about GH and IJ, so there is no way we can get those sides congruent. Also in this portion of the notes, I'm only finding side, angle, side. So we have to look at this parallel. We have not used it yet, we marked it. Parallel lines are still fair game. If I have two parallel lines, HI and GJ, cut by a transversal, HJ, we then create congruent angles right here. Those are called alternate interior angles. Nothing in geometry will ever go away. Yes, you still have to know that. Whoopsies, that's not my eraser. So the way you get your side, angle, side in this example is by using alternate interior angles. You have to use everything I give you in the proof. So if I tell you lines are parallel, the immediate thing you should be thinking is what angles are congruent. Since there are multiple angles at each vertex, do make sure to name them with 3 points. The J has to be in the middle to name the bottom one. The H has to be in the middle to name the top one. Your reason then is the alternate interior angles theorem. Now if you look at your picture, everything is marked. I have side, angle, side in this triangle. I have side, angle, side in this triangle. So I can tell you that the whole triangle is congruent. Again, use that statement they gave you at the top to help you name them correctly if you're still struggling with that. And your reason is side, angle, side. So the trick on this one, if I give you parallel lines, like in this given, look for transversals. If it helps, extend these lines to make it look more like our pictures from before. Sometimes that makes that easier to see, that those are alternate interior angles that have to be congruent. I think I have one more. Yep. We'll go through this one, and then you will have homework time. Again, go through and mark your picture. AB is congruent to CB. That was given to you, so that's easy. I'm given this other statement that BD bisects ABC. Bisects means that this angle ABC was cut exactly in half. So if ABC is right here and DB bisects it, what you know is this top piece, ABD, is congruent to the bottom. Again, everything is fair game. So if we fill that into our proof, that gets us a set of angles congruent. Make sure B is in the middle for both of them. And your reason is always use the word here. So the definition of bisects. Then we need another side, since I already have an angle. Looking at my picture, again, always go back to the picture. DB has to be congruent to itself because it is in both triangles. So DB is congruent to DB, and your reason, again, is the reflexive property. Now, always double check you have enough congruent statements. I have one with segments, I have one with angles. Here's my second with segments. They go in the correct order. If you look at the picture, again, your order is extremely important. This has to be between your two sides. Now you can tell me your triangles are congruent. And your reason is side, angle, side. On your homework, the first 6 problems, you are going to look at the pictures as marked. Tell me if they can be proven congruent, and you're going to tell me if it's side, 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 or side, angle, side. If your answer is yes, I need you to name the triangles. So tell me triangle ABD is congruent to triangle CBD, like in this last example. I would mark your extra information that is implied to you. Of those first 6, 5 of them are in fact congruent. 1 of them is not. Pay attention to order when you do that. Numbers 7 through 10 are all going to be proofs. I gave you extra lines on all of them, so know that you might not use all of the lines, and that is fine. Number 11 is a little bit of spiral review combined with what we did today, so think very hard about what you should be doing. If I give you ordered pairs and ask you to tell me if things are congruent or not, when you look at number 11. And that's all of your notes. Feel free to look back through them if you need to play it again. That way you can make sure you know what you're doing.